Hi there. So, a few days ago, I was talking to a friend about a new filament that I've been playing around with. This is the first flexible filament I've ever picked up and tried to print with, and it's an interesting material to try and work with. Definitely not the easiest thing to print with. But he was asking me a few questions there, so I figured I'd throw together a quick video, show you what I'm working with. So what I've got here is a spool of SainSmart brand flexible TPU. It's a gray material. Let me show you a detailed label here, if we'll focus. Yeah. May or may not be a filament that I'd recommend. One thing to note here, this is listed as a kilo of filament. I purchased this through Amazon. They have since changed their description to list this as 800 grams of filament. And looking through some of the reviews, apparently they've had some issues keeping the weight of their filament correct. But, you know, even with the negative reviews about that, even with folks saying that the diameter wasn't, quite perfect there, but it was still acceptable, the price was right, and I wanted to, start playing around with a flexible material. And, I am, in the end, happy that I bought this. Now, this is a very interesting material compared to ABS, PLA, or PET. You can take this filament, tie it in a knot, and it comes right back apart. So it is very flexible. Doesn't have a bounce quite like a rubber would, but it definitely doesn't, experience plastic deformation until you've put a lot of stress on it. And even there, yeah. But it is a more difficult filament to print with, and it had given me some issues and given me some pretty ugly looking prints the first few times I tried it. And I'm starting to get to the point where I can get a more reliable print out of this. So yeah, SainSmart 1.75 mil gray TPU flexible filament. Now the first thing to do there was dial in my extrusion multiplier and filament size and everything else. I'm probably a little bit spoiled because I'm used to eSun's filaments, and even though they are fairly inexpensive, they do have really good tolerances on their filaments. This I've seen vary from 1.62 to 1.66, so it's a little on the small side. It doesn't really have much variability, but it is a little bit smaller than what I'm used to, so I had to make some adjustments in my slicer to get it to print correctly. And that was the first thing that I did there. First test I ran was changing the extrusion multiplier every 5 millimeters. Now this is pretty typical of what I was running into at first when I was first trying to print with this. You see how we have a really ugly surface finish. We have a lot of pock marks and holes, and it just doesn't look good. And it was terrible at overhangs. That is probably the biggest problem with printing with this filament. Overhangs are a nightmare. Avoid them when you can, because they don't like to print correctly. But, again, really, really flexible and interesting material to be able to print with. Yeah. And this was done at 230°C, which turns out to be too hot. The manufacturer lists a very high temperature for this, and, again, back to a little bit of a questionable listing, at least as far as their listing on Amazon. It seems like they use the generic listing they use for all of their filaments, because I found that printing at this high temperature just does not give you a good result. Maybe for your first layer if you're worried about adhesion, but after that you want the temperature down. And that was the next thing I tested. At first we went from, here we go, 245 to 210 degrees. Once I had found a multiplier that worked for me, and just look at how we went from that ugly finish with all the pock marks down to at the very end when we were getting to our coldest, we ended up with a nice smooth finisher. Still a few defects, but this is a single layer. The other thing here is that I had to slow down the print speed, which, is typical of any flexible material. I was printing all of this at 30 millimeters a second. Yeah. So after seeing that it printed so much better at the colder temperature, I went even colder again. We started at 215 here, and I went all the way down to 180. And you just see how perfectly smooth it gets. You know, other than the few small defects when it finished each layer. Very, very nice looking layers there at the lower temperatures. So I went ahead and I tried printing a few test cubes there with various infills and so forth to see what we'd end up with. And the first problem I had when trying to print it at 180 degrees is that it just popped off the bed and ended up as a mess on the nozzle. So 180 might give you a nice exterior finish, but it doesn't really adhere all that well. And I am using a heated bed. I had it at 70 degrees there. It still didn't quite cut it. So I ramped it up to 200 degrees. I'm still getting a nice finish, and it stuck to the bed with no issue. So we've got two walls with no infill here, and we're still very flexible. Right where we have the right angle there, the hard corner, that's where it starts to get a bit stiff. But even the bottom is very, very nice there. And we can just crush this, fold it over. 2 layers on the sides, 2 layers on the bottom. And look at that. We'll pop out the dent. And she's going right back to where she was. Give that a moment, it'll be back. Yeah. So yeah, definitely some interesting things you can do with this that you can't do with any of the, hard filaments there. So that's with no infill. I then did a few at 15% infill. These are all at 15%. We have 2 walls, 3 walls, and 2 walls. The difference here is that this is 15% rectilinear infill, where it lays down lines in one direction on one layer, and then when it moves to the next layer, lays down the other direction. That's why it looks like there's so much more here than with the grid infill. And you see all the defects there, all the little gaps and strings. That's what happens when it tries to print over nothing. Because the filament is flexible and gummy, it'll drag on the nozzle, and it will just pull away if it doesn't have something that it's stuck to, even more so, and under, a layer underneath it. So this is, again, the 3 walls with the 15%, much stiffer because of that infill. No longer can I really fold it over or anything like that. So you can really vary the properties of a part with this material based on your infill and other settings. But still, in the right direction, it's got quite a bit of flex still. And it, returns to its normal shape. And this was the one with, the 2 layers there, same infill. A little bit more flexible, again, because of the thinner walls. Not 2 layers, yeah. And then we have the grid infill. Again, that looks like there's a lot less there, but there is about the same amount of plastic, or same amount of rubber in this case, because it's laying down twice as much each layer. It's laying down in both directions. And still very flexible. Stiffer at the corners. And most of what you do to it, it comes right back from. And then there was one more test cube here. This one was done with a rectilinear infill. But this was done at 50% infill. And this is an extremely stiff part. I can wrench on that. It barely moves. Yeah, the bottom got a little bit messy here because it didn't pull away from the raft quite perfectly. And I was using a single layer raft on these just to make sure they didn't move around. Yeah, let me get something a little bit beefier to try and torque on this with. So yeah, it is still flexible. It's a lot stiffer, and it still pops back. Yeah. So yeah, I've definitely got some plans for this. One of the things I'm thinking about right now is using this for printed grips on something like a camera holder or anything else like that. Now, let me show you something else interesting about this material. It's very difficult to cut with a regular knife. And I've got a hobby knife here. It's a fairly fresh blade. It's not perfect. Let me look around the camera so I don't cut my finger off here. But it's more catching and dragging than cutting. It's not an easy material to clean up with a knife. Oh, there we go. I was finally getting some kind of cut there. So it's a very different material to try and clean up. But there is an easy way to clean up, little stringy bits at the edges and so forth. And that's with a torch. Again, I'm going to look around the camera here just a moment so I don't burn my fingers either. And there we go. So it does respond to heat very well as far as cleanup. I've used hot air to re-smooth the part also. If the part is stiff enough, I found that you can go quite far with a controlled bit of heat, and I do have a hot air rework station, so I've got a little bit more control if I want to with hot air there. So yeah, you can almost completely remelt the surface to smooth it over there just using heat, as long as it's not thin enough that it's going to fold back in on itself while it's hot. And well, just because I've got it, let's try cutting with a scalpel as well. Gotta love cheap crap from China. So there we go, one surgically sharp blade. Let me grab, I don't know, this one again. Now let's try cutting the edge, and I'm going to be very careful here, because this blade will not give me any leeway. With a blade this sharp, yeah, I can actually cut into it in a fairly controlled manner. Still a little bit tricky, and I'd say heat is the quickest and easiest way to try and clean anything up there. Let me actually do something a little bit interesting here. I'm going to cut straight into this thing. Try and give you a side view. And just because that might be an interesting shot. Let's see if we can focus. Yeah, there's the side view. 50% rectilinear infill on a rubber part. And even with that cut, oh, yeah, it doesn't want to come apart. So this could be an interesting material for parts that need to be durable. One thing I have not tried yet, and I do want to try, is printing a timing belt with this, a GT2 belt. Either as a replacement for the printer or just to mess around with something less critical. If that doesn't become a stringy mess, then it could be really interesting. Yeah. Alright, so I think the last thing to try, because I did bring it up, is the hot air. I've got my rework station here. Turn it on. And, well, I've been printing at about 200 degrees. Let me drop it down to 200 degrees then, and we'll see what we get. There we go, 201. Again, I'm going to use the heavier infill part because that is more stable. See if we can focus. Focusing would be nice. There we go. Try to catch the light so you can see what we've got. I can't aim for anything through a camera. Let me actually stabilize this. Make it a bit easier on us. I want to get this where you can actually see the lines from the print layers there. And let's start applying heat. Alright, let's ramp up the temperature just a little bit. We'll go up to 260. This should be plenty to do a quick melt of the surface. And I'm going to hit the open edge for the heck of it. All right. Let that cool back off. Alright, so now that the rework station's cooled off and shut off, let's take a closer look at this. So here is the edge that we just warmed up. I started out with 200 degree air, brought it up to 260 to finish it, and you can see how much smoother that's gotten. You can kind of see the layers underneath the rubber, but the layers aren't on the exterior, and it feels very smooth. I can't feel the layers with my fingernail. Versus one of the normal sides, which if I catch the light correctly, and you can feel it, all the layers are right there. So that is one interesting thing you can do with this material. As long as there's enough support, you can get away with doing that. And it's not as easy as, acetone on an ABS print or anything like that, but you can get away with it. Now you see here, where I hit the infill, that's rectilinear infill, so there's a lot of airspace behind each and every one of those little extruded lines, and that started to cave in under the heat. And that's what I've seen with prints that don't have enough infill or shells when you try to warm them up, that are printed up in TPU. But that is, one interesting way to finish a TPU print. So yeah, hopefully I'll be printing more with this. Hopefully something more functional than just little cubes and so forth. But that is definitely something that I'm glad to have on the shelf there as far as my options for printable material.